Hey everyone, I want to talk a little bit for a few minutes about negative exponents. I say it's a little bit like living in an alternate universe because what does 5 to the negative 3 power mean? I mean, our universe, we know what 5 cubed means, 5 to the third power. We know that 3 in the exponent says to multiply 5 times itself 3 times, which is 125. And by the way, if we put 1 times in front of this whole thing, we still get 125, right? Multiplying anything times 1 is still itself. So how do we take this and try to make meaning or give meaning to 5 to the negative 3 power? There's a couple of ways to think of it. And one way is to look at it like this. Since a negative 3 is the opposite of a positive 3, it's an opposite sign. Since these are opposite signs, what's the opposite operation for multiplication? Well, that would be division. So instead of multiplying 5 by itself 3 times, we're going to divide 5 3 times. 1 divided by 5, divided by 5, divided by 5. And now we're going to take this and change these divisions. So 1 divided by 5, and I can write this as 1 times 1/5. Because remember, division by 5 is the same as multiplying by 1/5. So I can change each of these divisions to multiplications, right? 1/5 times 1/5 times 1/5. And if we simplify this, all those ones on the numerator get multiplied together. You give me 1. 5 times 5 times 5 is 5 cubed, which does equal to 1 over 125. But I'm more interested in seeing the exponents, that this 5 to the negative 3 is equivalent to, or is the same as, 1 over 5/3. So the negative exponent became positive, and we put it in the denominator of that fraction. So that may be one way to remember it. The opposite sign, right? This is negative 3, this is positive 3. So think of the opposite operation, which leads us to this division by 5 cubed. But that's one way to look at it. And I'm not totally sold on that. That's kind of a little bit waving the magic wand. I want to show you a way to look at this using the rules that we already know for algebra. We've established rules before, and we can't break those rules. So what do those rules tell us? I'm going to take a little side trip here. 5 to the third over 5 to the sixth. 5 cubed over 5 to the sixth. If I multiply out 5 to the third power, it means 5 times 5 times 5. So that's what we have in the numerator. And in the denominator, I got 6 of those guys. So when we start to simplify this, we can cancel this with that 5 with that one with this one, and this one with this one. And there's still a 1 up here that I just erased, but that 1 is still there. So I have 1 over 5 to the third power. So, okay, 5 to the third over 5 to the sixth is 1 over 5 to the third. But, look, we established a while back the quotient rule, which says when you're doing this division and the bases are the same, then this simplifies to 5 to the 3 minus 6 power. We subtract the exponents, which gives us 5 to the negative third power. So we cannot break the rules we've already established. And one rule tells us that 5 to the third over 5 to the sixth is 1 over 5/3. But we also know that it's 5 to the third over 5 to the sixth is equal to 5 to the negative third power. Well, the only way that can be true for this to equal 1 over 5/3 and also this 5 to the negative third power is for these two things to equal each other. They have to equal each other so that our previous rules are maintained. So let's generalize this now. Let's don't limit ourselves to a base of 5 and an exponent of negative 3. If we have any base x and any negative exponent, let's say negative m, we could write this as 1 over x to the m. This is how the rule is generally usually written, but I think it's helpful to think of it as x to the negative m over 1, even though it's the same thing, is equal to 1 over x to the m. So this is the rule. Now, if this is true, if these two things are equal to each other, think of it as an equation. Whatever I do to one side, I have to do to the other. So if I flip this side upside down, I'll have 1 over x to the negative m. And if I do that, I got to flip this side. So I'm going to have x to the m over 1. So this is also true. In other words, if you have a negative exponent in the numerator of a fraction, you can make that exponent positive by flipping the whole term to the denominator, flipping it upside down. If you have a negative exponent in the denominator of a fraction, you can make it positive by moving it to the top. All right, so let's see how we use those two rules to solve some of the homework problems. All right, so we have 3 to the negative 2 power. Let's first write this as 3 to the negative 2 over 1. And we can't evaluate 3 to the negative 2. That's one thing I want to make very clear. You never want to try to actually evaluate this. You have to make the exponent positive before you can evaluate it. So we make it positive by flipping it to the denominator. So we make this 1 over 3 squared. And now that we've got a positive exponent, we can evaluate it. 3 squared is 9. So we got 1 over 9. Same thing for this one. Negative 2 to the negative third power. I'm going to write that over 1. And then I'm going to flip it so that this exponent becomes positive. So this turns into 1 over negative 2 cubed. The sign of the base does not change. There's negative 2 base here. It's still a negative 2 base. Only the exponent changes signs. So now we have 1 over negative 2 cubed. Well, a negative 2 times a negative 2 times a negative 2 is a negative 8. So you have a positive in the numerator and a negative in the denominator, which makes the whole thing negative. All right, so this is the answer. If you enter it like this, it should count it right. My math lab should accept this. I personally would. Or if you enter it like this, also should be counted correct, as long as there's only one negative sign. But if you want to make sure that you don't get on the wrong side of my math lab, you can just place it out in front and it'll be counted correct.